Okay. So yeah, Nathaniel 今天没有 join，因为他有事情，所以 we proceed. And just for your info, again, this will be recorded. And also, today's lesson is very important because also not only it is in your exam, and also because when you miss a little bit, then the whole thing you don't know how to do. Okay, so I want your full attention for this one. Okay, so today we are going to talk about the Kirchhoff laws and the circuits calculation using the Kirchhoff laws. Okay, now, so 今天我们会开始 for 那个 revision 啦，因为你们一开学1个星期就考试了嘛，对不对？所以今天的 session 下个拜二的 session， 还有考试前可能我加了一个 session， 总共3个 session， 我们都会 focus on 你来这的the chapters that we need to cover. Okay, so this is one of the chapter, right? The Kirchhoff laws, mainly electricity. Okay, so let's start. Without further delay, let us start. Okay, so first is Kirchhoff law 是what is Kirchhoff law? Kirchhoff law 就很像 Ohm's law 这样子。你需要 Ohm's law 对不对 ？Ohm's law 是用来算 circuit resistance voltage current V 等于 IR。可是 Ohm's law 是用来 apply for simple circuit. Okay, what is a simple circuit? You can clearly see whether it is series or parallel, or even if it's combined, it's still you can clearly work out the resistance and voltage. But Kirchhoff law applies for a more complex circuit. Okay, for a more complex circuit, Ohm's law we cannot apply. We cannot calculate. Only when we use Kirchhoff law, we can calculate it. Okay, what is an example of a complex circuit? Complex circuit 就是比如说这样子。Okay, here I have a resistor. Here. And then we have a cell here. You have another cell here. Now you can already see this circuit, we got 2 cells. This one, positive, minus, positive, minus. Even though it looks simple, right? But 如果你看它的 current flow, current 从 positive 出来，然后这个 U current 从 positive 出来，这样它们就是相反哦。OK， 这样它们相反，它们的 current 是 flow 哪里呢？是 flow 左还是右呢？这样子我们不知道嘛，对不对？ So this is an example of a complex circuit. This is not even complex, you know. I can add here one more battery here, another resistors, and I join here. And then I add another one. This one, connect to a resistor, connect to another cell, then another resistor here, another cell, another resistor. Wow, you see this one. This is very complex. Okay, it's like a checkered board. Okay, you see many electric circuits, and all the component is here and there, here and there. The cell also mix up together. Okay, so this is an example of a complex circuit. If someone asks you to calculate what is the current flowing through the bulb here, current flow through 这个 bulb 多少？或者这里你的 computer, what is the current flowing through your computer over here? What is the voltage across this one? How would you calculate it? That is what we want to discuss today. Okay, so to calculate this type of circuit, we need to use Kirchhoff laws. Yeah. Now, this one, let's take one example of a very simple complex circuit. Okay, it is very simple, but it still looks complex. Okay, so let's take one example here. Over here. Then we have one more. Okay, now E1, E2, R1, R2, R3. Okay, here we have an example of very simple complex circuit. First, before we even talk about Kirchhoff's law, I want to introduce these three terms. 这个三个你要很清楚 ：junction, branch, 还有 loop。OK， 因为在 Kirchhoff's law 里面会用到 junction 是什么意思 ？junction 就是你看一个 point， 它有连接的，而且连接至少要有三个 wire。OK，for example， 这里 point A，this is a junction， 有连接三个 wire。You got 1 wire, 2 wire, 3 wire, 3 direction joining the point. That is a junction. 两个的呢不算，上面这边这个是 junction 吗？这个不是 junction， 这个只是 turning point 罢了。因为这个如果你 imagine 它可以把它打字，它也是一条线来的。OK， 所以有三个 branch 的才是 junction。So how do I define it? Junction, we said a point where minimum 3 parts meeting. Okay, 3 parts of wire or 3 directions meeting each other. That is a junction. So here 我们有两个 junction， 就是 junction A and also junction B. 2 junction here. This not a junction. Okay, second 讲到 branch. Okay, branch 就是a continuous path from one junction to another. What does that mean? For example, from one junction, let's say point A, this is a junction, right? A continuous path. So you take the path. From here, I go here, all the way to B. This is a path. To the next junction, which is B. To the next junction, not to the other junction. It's only from one point to the next one. That is a branch. Okay? Now, how many branches are there in this circuit? You can see, I can go here. The first branch is A, R2, B. I can also go up here, right? So go E1, R1 to B. That is another branch. I'm still going from junction A to junction B, but it's taking another path, right? And then I got the third branch, right? A, go down, E2, R3, and B. Okay, now, so a branch, how do we define it? It is a continuous path from one junction to the next junction, not other junction. Now, what are the few things that we need to know about branch? What is its specialty? Remember, 记得 branch 在一个 branch 在某一个 branch 里面current 是一样的 okay, the current flowing, the value of the current is the same. In one branch, the value of the current do not change. If I say that this branch is 2 ampere flowing here, then you know what branch is this. 这一个 branch 是 A, E1, R1, B. 所以这里也是2 ampere, 这里也是2 ampere, 这里2 ampere, 这里也是2 ampere. 从这里到这里全部都是 it belongs to one branch, the same branch. On R2, the other branch here, I, is this 2 ampere? We don't know. But we know that 2 ampere is only in this branch. We are certain that this is the same. No current change, okay? It's the same current. So I can conclude that in any one branch, current do not change. Okay, what current do not change? Value of current do not change. So right here. Okay, value of current do not change. This one have to remember. And usually, branch 是多过 junction 的。Okay, 如果你有2个 junction A、B， 你就会有3个 branch。这里。Okay, is more than, usually is more than the junction. Okay. Okay, now next one is the loop. Okay, what is a loop? Loop is a combination of branch. Okay, so loop 如果你 start 一个地方，你走一个 continuous path 哦，你要回到原点，那个才叫一个 loop。你不可以 stop somewhere, somewhere in the other point. No, you have to come back to the same point. Okay, so for example, point A. If we start from point A, we go around the circuit. Where do you want to go? Whatever direction you want. Okay, let's say we go up. A, E1, R1, B. Can I stop here? No, I cannot stop here. This is not a loop yet. I have to come back to R2 and then come back to A. Then this forms a loop. So it is a combination of branch. What branch? There are two branches here. 上面这边跟这边，这个两个 combine 加起来，你拿到一个 loop. Okay, so here loop is combination of branches, can be one or more. It is also called as the continuous path, starting and ending at the same point. Okay, so one of the examples we have just talked about it. First is the first loop, loop 1. A, E1, R1, B, R2 然后回来 A. 从这里我去我回来是一样 A. This is one loop. How many loop are there? Another loop, loop 2. 我可以走下面，对吗？ A 我去 E2, R3, B, R2 再回来 A. 这个也是一个 loop. Is there any other loop? Yes, there's one more, right? Loop number 3. I go the outer circuit. A, E1, R1, B, R 3 E2 回来 A. This is the third loop. Okay, so first loop inside the upper loop. Second loop here, and third loop is the bigger one, outer one. Now, do you need to start from A? Not necessarily. You can start from any point you want. If I start from E, then I have to only make sure that I come back to E. That also forms one loop. Okay, so now junction, branch, and loop, you need to be able to differentiate. And also, what we understand about Kirchhoff's law. Kirchhoff's law or Kirchhoff's rules are used to calculate current through different elements in a complex circuit. The main purpose of Kirchhoff's law, 它是用来算 current through different elements. What are the elements in a circuit? It can be a resistor, it can be a inductor, it can be a cell, it can be whatever electrical component is an element. Okay, so Kirchhoff's rule used to calculate the current passing through any component I want, provided that the circuit is very complex. Okay, I can use it to calculate. Can you use Ohm's law? This one cannot be achieved by, cannot be understood by your simple Ohm's law calculation. Okay, because in a complete circuit, in a complex circuit, 你不可以用一个 equation 来 define 它。No, you have to have many equations. That's why we don't use Ohm's law. Okay, now 这里我们已经讲了 junction, branch, and loop, right? And also the Kirchhoff's law in general. We are going to start to look at the law. What is the law saying? Okay, now first one, let's go to the next part. Kirchhoff's first law. Okay, Kirchhoff's first law 它是讲到 junction law 或者 current law 一样的东西，只是不同名字罢了。OK， 因为它是 junction law，OK，it is sorry， 因为它是 current law， 所以 it is applicable at junction. This one, the first law only apply for the junction. Okay, so focus on the junctions. Now, what does the first law says? It says that, okay, at any junction, the algebraic sum of all the current is 0. Basically, this is what it's saying. Okay, what does that mean? At any junction, the algebraic sum of all the current is 0. 什么意思是 algebraic sum? Algebraic 就是有加有减有 sign algebraic sum 就是I have to deal with the plus minus. 我一定要 include 买那种加减的 operation. Okay? 有 direction 的意思。Okay? 有 negative sign. Okay, so at any junction, the algebraic sum of all current is 0. 意思说 let's say 我们这边有一个 junction, and then 你有4条 wire connecting here. Current approaching 那个 junction, this is 5 ampere, this is 4 ampere. Current approaching 那个 junction, 我会给它一个 sign, 我给它 positive sign. And then current leaving the junction, 我给它一个 sign, negative sign. Negative 3, now negative 6 ampere. Okay, if you take the sum of the current at this junction, this one, positive 5 plus positive 4, positive 5 plus positive 4, plus minus 6, minus 6, minus 3. Okay, I'm adding it up algebraically, right? I'm taking the algebraic sum. Plus everything, you get what? You get this one, 9 minus 9, then you get 0. So I can say that the sum of the current, sigma I, means the sum of the current, is equal to 0. Okay, so how do you get 0? Actually, it cannot be 不可以全部 current 去那个branch, sorry, 不可以全部 current 去那个 junction 的，对吗？如果你要拿到0 sum 是0的话，你一定要是有一些 current 是出来，不可以全部 current 都是，不可以4条都是去那个 junction. It has to be some current that is flowing out. It has to be some negative there. That's how you get 0 sum. Okay, so what are the negative? This one, and this one. Okay, so sum I is positive, sum I is negative. That's when you get 0 sum. Okay, 这个是什么意思呢？这个 expression it simply tells you current approaching a junction 等于 current leaving a junction. That's it. Please take note of this statement here. Current approaching a junction equals to current leaving a junction. 你有9 ampere 去这个 junction, 9 ampere 也是走出来。Okay, so let's look at one example here. Let's say, okay, I have a circuit here now. Okay, like this. This is 2 ampere. 这个3 ampere. 这里1 ampere. 2 ampere, and this is 3 ampere. Identify the current using the Kirchhoff first law. Okay, so 2 ampere 走这边，3 ampere 走这边，它们是什么 approaching 对吗？2 ampere and 3 ampere approaching 这个 junction， 然后 equals to current leaving. So 这里是5 ampere. 如果你要算它的 sum approaching 我们放加5 ampere 我们放减，它是 leaving so it's leaving negative. You plus it, 2 ampere plus 3 ampere minus 5. The sum would be also 0 at this junction here. Okay, so 5 ampere 走过来，1 ampere out， 剩下4 ampere 走这边。Okay, 4 ampere and then 2 ampere coming in here. So here you get 6 ampere. and 6 ampere crosses this junction, 3 go out, left another 3 ampere here. Okay, so with the first law, you are able to identify what is the current in each branch. Why this? How do they get the first law? What is the first law based on? It is actually based on the principle conservation of charge. Okay, so sometimes we have to understand why is it like that. Conservation of charge or conservation of energy, same thing. Okay, conservation of charge 它是讲哦，你有 let's say 你有 X amount of charge approaching 那个 junction， 那个 charge 哦，它不可以 stay 在那边，它一定要走。多少个 charge 进来 junction， 它一定要一样的 charge 离开。OK， 因为如果它不一样的话哦 ，let's say 你有5 ampere charge，5 ampere 是 current 对不对 ？current 就是 flow of charge 嘛。5 ampere 走进来，然后你只有2 ampere 出去，这样你的3 ampere 在哪里？你的3 ampere 是 stuck 在那边。OK，so 如果你的3 ampere stuck 在那边是这样子，意思说 over time 哦，你会有越来越多的 charge 在那边。So there will be a charge accumulation, a charge build up at the junction. And this is not possible. Okay, according to the conservation, this is not possible. Whatever the charge, how many charges coming in, it has to go. So that is the base of Kirchhoff's law. Okay, conservation. Whatever coming in, it has to go. It cannot stay there. The charge cannot stuck there. The charge has to continue flow. Okay, that is Kirchhoff's first law. Okay, now then next one we look at Kirchhoff's second law. Second law is known as the loop law. What's it? The voltage law. There are only two types only. And it is the voltage law and it is applicable to loop. Yeah. So what does the second law says? Let me write this down. In any loop of an electrical circuit, okay. So you got in any loop of electric circuit, the sum of the potential difference is voltage, the sum of the voltage across different elements is 0. What are the elements? It can be a resistor, it can be a bulb, anything, cell, anything. Okay, so here I can write the sum of V 是等于0。OK， 刚才那个 sum of I 等于0嘛，对不对？这个是 sum of V 等于0。In any loop, okay, what does it mean? For example, let me give you one example here. Let's say we look at a circuit. Okay, R1, R2, R3, E1, E2. Example, when we look at one loop, let's pick any random loop. Okay, 我们选 okay, point A, loop number 1. We choose A, E1, R1, B, R2, now come back to A. This is loop number 1. Okay, this one up, the upper loop. Now focus on only this loop. Apply the second law of Kirchhoff. 他讲什么？他讲在一个 loop 里面的总共的 potential difference 是0，对吗？ The sum of all potential difference. Now 如果你要拿总共等于0，意思是说有一些是 positive， 有一些是 negative。OK， 有一些的 potential difference 是加，有一些是减，你才可以拿到0嘛。如果全部是加，你哪里拿到0 Okay, so there are some negative voltage, there are some positive voltage. Okay, now, how do I know? How do I calculate the voltage? Now, here is the very, very key important note. And before you do the calculation, before you find out the voltage, you need to first distribute the current. Okay, 意思说 before 我们做 voltage，before 我们做 Kirchhoff's second law 的时候，是我们要先做好 Kirchhoff's first law。First law 是讲到 current 对吗？所以我们要首先找 current 的 direction 在哪里先。你要先 distribute 那个 current 先 ，before 你算那个 voltage。Okay 啊 ，understand this one. So before we start this, we first distribute the current. How do we distribute the current? 我先找 current 的 direction。Okay，now current 的 direction 呢？因为一来我们不知道 current flow 哪里的。OK， 我们不知道 flow 哪里，因为你看到这个电哦，它从这边走出来哦，它可以 flow 下去，然后这个电从这里走出来，它又可以 flow 反方向的哦。我们不知道嘛，一来，所以我们先放出一个 sign 先。It's okay, you can choose any direction. Okay, don't worry about it. Later you will know how to find the correct direction. Okay, now here's a simple tip to find the current. 首先，我们用那个 battery 的 positive 来做我们的 guideline。OK， 我们从这个 positive battery 画 current I1。OK，I just label whatever unknown I1， 然后这里的 battery， 这里的 current 也是 I1 对吗？因为它 flow 去那个 junction 嘛。它的 current 一定是这个方向吗？不一定啊，我还不知道，我先放这一个 direction 先。OK， 我怎样放？我用那个 battery 的加来帮我放。这里也是一样，从这个 battery 出来 I2。OK， 去到这个 junction I2。OK，now 这个 branch 哦，上面这个 branch， 刚刚我讲了什么 ？current 是同样的，在同一个 branch， 所以从这里到这里全部都是 I1， 这里 I1， 这里 I1。这里也是 I1 direction 你就跟着它咯 ，OK， 从这里 flow 这里，这里也是一样 I2， 然后 I2， 这里也是 I2。How about the branch at the middle? Okay, how about the branch at the middle? So the branch at the middle, this one enters, this one enters. So current leaving here is I2 plus I1. Okay. On the other end here also I2 plus I1. 所以你可以好像 double check 这样子啦。你看 I2 plus I1 哦，走去 junction B， 然后他们也是出来也是 I1 跟 I2。Okay. So this distribution tells me that so far it is correct. I will stick to this distribution of current. Okay. So what is it that you need to remember again? Before you start Kirchhoff's second law, you do the first law first. Distribute the current. Now, after you distribute the current, what do we do next? Okay, now this is very, very important. This is the point where many students fail to calculate this. It's because of this one. Okay, now after we distribute the current, 现在我们要找的就是 Kirchhoff's second law 对吗？ Before 我们找 Kirchhoff's second law 的时候，我们先要 identify, okay, identify, not identify, I would say choose direction of calculation. Okay, so choose direction of calculation. How many direction of calculation is there? Okay, we focus on one loop. We focus on one loop. Let's say loop 1, this one, from A to E1 to R1, B R2 回来 A， 这个 upper loop。OK， 我们 apply 这个 Kirchhoff's second law， focus on 这个 loop， 然后我们要选我们的 direction of calculation。你可以走 clockwise 或者 anti-clockwise。当你一选 clockwise 的时候，你就要 stick to clockwise。 不要算到一半，然后你调转 anti-clockwise. No. Okay. The direction you choose, you have to stick with it until the end. Okay. Now here's what I mean. Okay. Let me draw the upper circuit here. Okay. Let me draw this upper circuit here so that we can do it bigger. Okay. 这个是这 and here we take the upper loop. Okay, this is R1, this is R2, this is my point A, this is my point B. E1. Okay, 然后我们放我的 current direction I1, I1. This is 这里是 I2 加 I1 对吗？这里是 I1。Okay, now 现在我们选了我们的 direction of calculation， 我们要走 clockwise 还是 anti-clockwise？ Okay, 我们 let's say 啦，我们走 clockwise. Okay, so we go clockwise. Now if we go clockwise, then 从这里开始，其实你从哪里开始都可以的。Let's say 我从 A 开始，我从 A 我走 clockwise， 我上来走去 the first component, which is the cell, the battery。这里我会写 V1， before 那个 battery V1， after 那个 battery 我放 V2， meaning that the first point and then the second point。Okay, now 我去到下一个 component， 这里也是我的 V1。After that, 我的 V2. Point 1, point number 2. 我可以写 V2 在前面吗？不可以，因为我是现在走着 clockwise， 我要 stick to 这个 direction. Now, 继续走这里到 the next one, R2, right? This is my first point, V1, and this is my second point, V2. Okay, until here. Now what do I do? After I put in all this point, then I focus on this one. I got 3 components here, right? I got 3 components here. This one, I'm going to take, okay, this is the battery. This is V1. This is V2, right? Now, for the battery, right, guys, for the battery, 哪里是 higher potential? Higher potential 是哪里？ Positive plate 是永远是 higher potential 的，记得 ，OK？ 因为 current 从 positive 走嘛 ，current 是 flow from high potential to low potential， 很像水这样子，水 flow 从 high pressure 去 low pressure，so current is the same 啊 ，it flows from high potential to low potential。Positive plate 是 high potential，negative plate 是 low potential。OK 啊 ，so 我们拿 V1 minus V2。After you distribute this one, V1, V2, we always take V1 minus V2. We always take point number 1 minus point number 2. Okay? Meaning that this one, 我们用 V1 减 V2. 第二个也是 V1 减 V2. 第三个也是 V1 减 V2. 你不可以突然间，我要 V2 减 V1. Please no. This is the reason why so many cannot do. Okay? The direction you choose, you have to stick to it all the way. You choose clockwise. Whatever the point before the component is 1, after is 2. Then we take V1 minus V2. The next one, V1. After that, V2. V1 minus V2. The next one, V1. After that, V2. 也是一样 V1 minus V2. Okay 啊 So 先看那个 battery V1 minus V2 对吗？哪一个是 higher potential? V1 高还是 V2 高？ V1 的 potential 比较高，因为它在 positive plate 那一边。所以如果 V1 比较高，这样 V1 减 V2 你拿到什么？你拿到 positive V。大减小吗 ？Okay, so 你拿到 positive voltage for the cell number 1。接下来我 analyze resistance number 1。Okay, so this is R1。这里是我的 V1 对吗？这里是我的 V2。 current flow 哪里？看这个 I1 呢 ，I1 是去左边，对吗？所以 current I1 是这边 flow 去左边 I1。OK，so for 这个我们也是用 V1 减 V2 等于多少？那这个怎样知道哪一个比较大 ？Battery 我可以直接看它的加减，这个哦，我用 current 来帮我。current 是从 high potential 去 low potential， 所以如果这个 I1 是去左边的话哦，意思说 V2 是 high potential，V1 是 low potential， 所以 V1 减 V2 你会拿到什么？你会拿到减 V， 因为你用小减大嘛 ，OK， 减 V，OK 啊，那减 V， 你的 V 是等于 IR 对吗？我可以 express 去 IR， 所以我可以把它写成减 I1 R1。This one is just Ohm's law, right? The voltage across this one is the I1 times into the resistant one. So I can just write it like this. Negative I1 R1. This is the voltage across R1. And it is a negative. Okay, now 第三个 component R2. Okay, so here is my R2. 这里是 V2 嘛，对不对 ？V2 V1。Current flow 哪里 ？Current 是 flow 去右边 I2 加 IE。我要用什么减什么 ？V1 减 V2。我已经 define 了我的 direction 对吧？这个是我的 direction of calculation。OK， 那 V1 减 V2， 哪一个是 higher potential？Current 从左去右，所以 V2 是 high potential，V1 是 low potential。V1 减 V2， 你也是拿到一个 negative value，so 减 V 等于 IR 对吗？所以减 V I2 加 IE， 这个是 I， 然后乘以 R。OK 吗 ？If you have any question, please stop me. Okay, so you get this negative I2 IE R. Back to point A. Any other component? No component. Only 3 component. So I have worked out this voltage across each one. I can write the sum of each one is equals to 0. So V 减 I1 R1 再减 I2 plus I1 R， 这个总共等于0，因为我的 second law 讲 sum of potential difference is 0。OK， now OK，我 create 多一个 link， 然后我们在那边继续。